Hi everyone, my name's Alex. I'm a Principal Solutions Architect specialising in observability. And today I'm going to talk about AWS Observability. I basically created this course on AWS Skill Builder. It's a 5-hour course on various aspects of observability on AWS. And we're going to kind of go through what's possible on AWS and a little bit about the course and what's achievable and then what you can learn in the course. Okay, so just a bit about Skill Builder first. So we've got a digital training library of over 600 courses, and they're available on demand anytime, anywhere. And these include foundational and advanced content across a number of different AWS services and solutions such as machine learning, IoT, storage, and obviously observability. And this is a kind of cost-effective way to get some training, because there's no charge for some of the digital training courses, and it's developed and built by AWS experts. And hopefully that ensures that you deploy your services in the right way. So we've got this different training that meets different needs. We've got role-based training, for example, for architects and developers and operations. And some of it's domain-specific, as I've said, such as machine learning and observability. And some of it's service-specific as well, such as training specifically for Lambda. And we've got training for different levels of expertise as well, for foundational, intermediate and advanced. And this observability course is kind of from foundational to intermediate. And as I said, this is available anytime and anywhere. And you've got the ability to stop and resume the training whenever it's convenient for you. And we add to this content all of the time as we release new services and new capabilities, and making sure hopefully that you've got access to the most recent information and training. So if you go to skillbuilder.aws, you can learn more about the digital training. But I'll give a link later on. So it's all about kind of owning your own career, developing your skills, and hopefully learning in the right way, in a way that suits your time and availability. So I'm going to start with asking kind of what is observability? Well, a guy called Robert Kalman invented the term in a paper. It was actually about manufacturing in 1960. And his premise is that you couldn't control or optimize a system unless it's observed. And the modern definition that we have, that AWS have, is that observability describes how well you can understand what's happening in a system, often by instrumenting it to collect metrics, logs or traces. And today I'm going to talk through what you can learn in the AWS Observability Skill Builder course and why observability is important. And you'll learn about the 3 pillars of observability: tracing, monitoring and logging. And you'll also discover a wide range of services that will help you with cloud operations and transforming them from a tactical day-to-day routine into a strategy that will help you deliver business outcomes. And this course, this Skill Builder course, is for engineers, developers, site reliability engineers, cloud architects, cloud operations, and anyone else that's interested in observing their applications or infrastructure. Okay, so you've built your first application in AWS. So now what do? Well, observability helps you, amongst other things, to prevent or detect failure, improve your customer experience and reduce costs. If you've ever seen a talk by Dr. Werner Vogels, he's the VP and CTO at Amazon, he says 2 things. One, that security is job number 1. And in almost every talk he says, everything fails all the time. And no code or infrastructure is perfect. Unless you've got extremely lucky, there's probably some failure is going to happen or has already happened to you. And observability lets you understand your application's health, helps you know what's going on anywhere and everywhere in your system, and to provide the best possible experience for your end users. And that's what's important. The experience for the end users, for the customers. It should help you detect problems quickly, investigate efficiently, and importantly, remediate as soon as possible if something does go wrong. And here at Amazon, we focus on you, our customers. Jeff Bezos, the founder and executive chairman at Amazon, said that even when they don't know it, customers want something better, and your desire to delight customers will drive you to invent on their behalf. So everything we do is focused on our customers, and we call this customer obsession. And observability helps, and it helps you measure the customer experience. And you can use this data to help elevate your customer experience and improve your business outcomes. And when you improve your application, infrastructure, and things like network availability, and reduce downtime, and build faster, and create a better experience for your customers, it's better for your customers and it's better for your business. And this allows you, both your internal teams and the end customers, to benefit. And when you understand your application's performance and the utilization of your resources, you can then optimize and reduce your operational cost as well. I mean, across hundreds of thousands of instances, even a small percentage improvement in how much CPU an application uses could end up saving millions of dollars. Similarly, by using observability to understand and predict your future capacity needs, you can take advantage of cost savings available from things like reserve instance pricing or spot pricing. It's also important that you don't let customers spot issues before you do. And monitoring and alerting will allow you to take actions when things break, but also proactively you can prevent failure by gaining insights into your applications before they reach a breaking point. The person who's said to have invented modern business management, Peter Drucker, is credited with saying that you can't improve what you don't measure. And this is true of your applications as well. And just a final point here, remember that operations are forever. The moment you release something into production is when you need to start observing it, and you'll need to do that forever. And think about maybe when was the last time you decommissioned an application? It doesn't happen very often. So I'm going to talk about the three pillars of observability now. So I already mentioned that we've got these three pillars: metrics, logs, and tracing. In the AWS cloud, the three main services that provide these pillars are Amazon CloudWatch Metrics, CloudWatch Logs, and AWS X-Ray for traces. Metrics are just a simple numeric representation of data over intervals of time, or time series data, and they're useful for identifying trends, mathematical modelling and prediction. And logs are immutable time-stamped records of discrete events that happen over time, and they're useful for uncovering emergent and unpredictable behaviour, and also for troubleshooting. And traces are a representation of a series of related distributed events, and they encode the end-to-end request through a distributed system. Essentially, they record a transaction, and they provide visibility into things such as latency, into the path traversed by this request, and the structure of the request as well. And I'll show you this in a bit more detail later. With CloudWatch, you gain system-wide visibility into resource utilization, application performance, and operational health. And AWS X-Ray provides a complete view of requests as they travel through your application. And you can visualize data, across different payloads, functions, traces, services, APIs, either with no code or a low code implementation. And these three pillars are what make up the building blocks of making your application observable. And in the AWS Observability course, you can learn how to collect and analyze data from metrics, logs, and traces. So we can also augment these with open source managed services. And you shouldn't think of whether you should use open source or cloud native tooling across your entire platform. Instead, you should consider what tools are right for the right circumstances. So with open source managed services, you have more choice. Amazon Managed Grafana is a fully managed service for Grafana, which is a popular open source analytics platform that enables you to query and visualize and alert on metrics, logs and traces. You can use Amazon Managed Grafana to visualize data from multiple sources, such as Amazon CloudWatch, X-Ray, Amazon Managed Service for Prometheus, other cloud providers, open source tools, observability partners and ITSM partners as well. And this allows you to work towards creating that kind of single pane of glass view that everyone wants for their application or infrastructure. The AWS distro for Open Telemetry is a secure and production ready AWS supported distribution of the Open Telemetry project. And with the AWS distro for Open Telemetry, you can instrument your applications just once and send correlated metrics and traces to multiple AWS and partner solutions. Amazon Managed Service for Prometheus is a Prometheus compatible service that monitors and provides alerts on containerized applications and infrastructure at scale. The service is integrated with Amazon Elastic Kubernetes Service, EKS, and Elastic Container Service, ECS, and the AWS distro for Open Telemetry. And you can use the Amazon Managed Service for Prometheus mostly if you're already using Prometheus and you're already familiar with Prometheus and you're using self-managed Prometheus and you want to remove that undifferentiated heavy lifting required to build, patch, upgrade and maintain Prometheus. And in the observability course you'll learn how to collect data using the AWS distro for OpenTelemetry, how to send that data to Managed Prometheus and how to visualize that data in Managed Grafana to build dashboards. Okay, so now I'm going to do a demonstration of the ServiceLens map. That's going to show you a bit about tracing and metrics. So I've got a very simple application, demonstration application here. All I'm doing is searching for films in a particular year. So this is my web application. I can search for a year and it will return all the films made in that year. I've also got an API. I'll make this a bit more visible. At the moment it's just search for films from the year 1920 and it's just returning JSON. So I'll do the same thing. I'll search for 1995. That's too far in the future. And we get some JSON returned with the plot of the film, the year the film was released, and the title of the film. So what I'm going to show you now is the ServiceLens map. So this is in the CloudWatch console under Application Monitoring, ServiceLens map. And I'm going to show you a group that I've created that makes up part of my application. And in this application, for the API, I'm using an Amazon API gateway and a Lambda function, and the Lambda function is calling a DynamoDB table to get the movies from. Now the red here indicates that I've got a problem. I've got some faults. So I'm going to click on this, and we can see here some of the issues we've got. So we can see some metrics on latency. So my latency is pretty good, but then I've got some spikes here that are going up to about 27 seconds. We can also see that these correlate with faults that I have as well. So this high latency correlates with these faults. So what I'm going to do is click on this checkbox here, and then I'm going to click on View Filtered Traces, and this is going to show me traces where these faults have occurred. So at the bottom here I've got a list of 5 traces where this fault's occurred over the last 6 hours. I'm going to click on one of these. And the first thing I see is a map. So here I'm using a synthetics canary to perform a synthetic transaction every minute. That's going through my API gateway to my Lambda function. This Lambda context is just what contains the Lambda function. And this Lambda function is making calls to the DynamoDB service, and then it's making a query to DynamoDB. Below this, I get a timeline of everything that's happened in this single transaction. And I can see some faults here. And actually the fault has happened downstream, and it's happened in the Lambda function when I'm calling DynamoDB. So I can click on this fault, and I get an overview here. So I get an ID of the trace, and in this case it's of the subsegment of the trace, a part of the trace, when it happened, the duration. So this took almost 26 seconds, and it should take far less than a second. It tells me that there's a fault. I get some information linked to the resource, so which region it's in, some information about the query, the fact that it was a query, and the table name that I've used. Optionally, I could add data that can be indexed so I can search my traces more efficiently. And I can also add metadata, but the important thing here is the exceptions. So when I look at the exceptions, I can see that I've got an exception here, provision throughput exception, and I've got a message as well. So an error occurred when calling the query operation. The level of configured provision throughput for the table was exceeded. Consider increasing your provisioning level with the update table API. I also get a stack trace, and this tells me where my error occurred in my Lambda function. So I'll just zoom in there. So it happened on line 32 of my Lambda function. So I could go and look at my Lambda function and see what happened if I needed to. But I know from the error message I've got an issue with DynamoDB. So let's take a look at DynamoDB and look at this table. And if I scroll down, we can immediately see where the problem is. My provision throughput, my provisioned read capacity is 1, and my read usage is above 1 most of the time, and this is why I'm getting throttled. So if I were to go to the settings for this table and edit the settings and change this to, let's say, 10, and save the changes, then that would immediately resolve the issue. Now I'm going to go back to this view again, because another feature of this view, I'll just close that, is you also get correlation with logs. So you get this built in with API Gateway and AWS Lambda, and you get a correlation with log events from API Gateway and AWS Lambda. So in this case, I've got a log event here, and I've got the same error, unexpected error, an error occurred, and it's the same error. So that's kind of giving you an overview of kind of what's achievable with when you implement tracing and you use the ServiceLens map. So again, I could go through this pretty quickly. I can see that there's an issue. I could click on the issue. I could immediately go to the faults. I could view all the traces that contain this fault. I could pick one of them. I could find the fault, find the exception, and I could, within a minute or so, find the root cause of the issue. So let's go back to the presentation. So, observability is everything. During a keynote speech, Werner Vogel's declared that this observability is everything. And as we've discussed, it's is vital for detecting issues, making improvements and reducing costs. You can't really operate an application without observability unless you just happen to get lucky. And so far I've talked about collecting metrics, logs and traces, and I've shown you a demo about how you can use ServiceLens map to visualize and troubleshoot issues. But this isn't really enough to make your application truly observable. So you've collected telemetry, now what? Well, just recording information is not enough. You need insights into that information. And in the observability course, you'll learn how to query and analyze your metrics, your logs and your traces to identify trends and patterns, or for troubleshooting. And the course explains the fundamental concepts of how metrics are collected and organized in CloudWatch metrics and how they're retained. It also explains how you can use statistical and machine learning algorithms using CloudWatch anomaly detection to surface anomalies with minimal user intervention. And you'll also learn the principles of CloudWatch logs, how they're organised, their retention settings, and how you can extract metrics from log events. And this can be useful for surfacing metrics that maybe developers have exposed in logs but maybe are otherwise difficult to obtain. The course covers using CloudWatch logs insights to interactively search and analyse your log data in CloudWatch logs. You can perform queries to help you more efficiently surface and respond to operational issues. You'll also learn how to use contributor insights to analyse log data and create time series data in real time. And this shows you like the top n number of contributors to, let's say, the top 100 IP addresses that are accessing a website, for example. And this helps you to find top talkers and understand what's impacting system performance for high cardinality metrics. And you can do things like find bad hosts, identify heavy network users, or maybe find URLs that generate the most errors. And it also goes into more detail about analysing trace data using the ServiceLens map that I just showed you, and how to automatically uncover anomalous behaviour using X-ray insights. Amazon Managed Grafana can visualise CloudWatch metrics, Amazon Managed Prometheus metrics, CloudWatch logs and X-ray traces, and that's also covered in the course. So what about containers and Lambda functions? So you may start to be thinking about microservices architecture, or you may already have some applications using containers or serverless functions using AWS Lambda. And that's a compute service that lets you run code without provisioning or managing servers. And so how do you gain more insight into how your containers or your serverless functions are performing? So CloudWatch Container Insights collects and aggregates and summarises metrics and logs from containerized applications and microservices. Container Insights is available for both Amazon Elastic Container Service, ECS, and EKS as well, and also for Kubernetes platforms on EC2. Container Insights supports collecting metrics from clusters deployed on Fargate for both Amazon ECS and EKS. CloudWatch automatically collects resources from such as CPU, memory, disk and network, and it also provides diagnostic information such as container restart failures to help you isolate issues and resolve them quickly. You can set CloudWatch alarms on these metrics to alert you, and CloudWatch Lambda Insights is a monitoring and troubleshooting solution for serverless applications running on AWS Lambda. And this solution collects, aggregates and summarizes system level metrics including CPU, memory, disk and network. And it also collects and summarizes diagnostic information such as cold starts and Lambda worker shutdowns to help you isolate issues with your Lambda functions and resolve them quickly. And you can learn more about how this insight tool works and how to use them to identify issues and improve performance in the course. So I'm going to show you a quick demonstration now of Lambda Insights. Lambda Insights has both a multi-function view and a single function view. In this multi-function view, I can see all of the Lambda functions in my account. I've only got 3 running at the moment, and I get all of these different metrics, and I also get a summary here as well, so I can see each function, the number of invocations, the number of cold starts, how much memory I'm using, the maximum memory, CPU time, and network I/O. And this is useful for getting an overall view of how your functions are performing. But I'm going to go and look at the function that's delivering results for my API. And then we get some individual information about this function. So we get invocation and errors for this function, duration, throttles, memory usage, CPU usage, and network usage. But what we also get here is a view of the last 1,000 invocations. This is linked to the trace, so I could click here and view the trace. We see the duration, we can see memory usage, CPU time, and network I/O as well. We can see here, this is an example of where I've had an issue. I could go and view that trace from here instead, rather than using the ServiceLens map if I found the issue here, and I could go directly to that trace and see what we saw earlier. I can also view application logs directly from this console as well. So here I can see the last 1,000 application logs. So this is another way, if I saw an issue with my Lambda function, I may be able to view to see the log information and see the issue directly from here, or I could click on view logs, and then I'd be able to view the logs inside log insights query, and it will automatically choose the log group that I need to search, and the timescale will match the timescale that I had here, which was the last 6 hours. So you can see here, this is for that 6-hour period, and this is just getting the last 20 log events. So how do we create alerts? So you've got telemetry and insights. You now need to create alerts. And a metric alarm watches a single CloudWatch metric, or the result of a maths expression based on CloudWatch metrics. An alarm performs one or more actions based on the value of the metric or an expression relative to a threshold over a number of different time periods. And this action can be sending a notification to an Amazon SNS topic, or performing an EC2 action, or an EC2 auto-scaling action, or you can create an ops item or an incident in Systems Manager. And when you send an alarm to an SNS topic, this allows you to send notifications, or you can then process the alarm with a Lambda function to maybe enrich the data or interact with other tools for paging, for instant messaging, or to interact with ITSM tools for creating an incident in your ITSM tool. You can use Amazon EventBridge to monitor and alert on metrics based on events. So you can also schedule operations tasks by running, let's say, a Lambda function or a Systems Manager automation document. And you can do this either to a schedule, or you can do it in response to an event, including an Amazon CloudWatch alarm state change. So you could use an EventBridge event, and that the cause of that event could be a CloudWatch alarm, and therefore you could trigger an action such as a Lambda based on that changing state. And that means you can trigger something to happen when the alarm goes back to a normal state, so everything being okay, you say, right, well, I want to trigger some kind of automation when things are okay again, and that might be, let's say, closing the incident in your ITSM tool. And in the observability course, you'll learn how to create and use CloudWatch alarms, and also how to use EventBridge. And also, you need dashboards. You can't rely on dashboards though as a mechanism for identifying issues, but they are important. CloudWatch dashboards are customizable home pages in the CloudWatch console that you can use to monitor your resources in a single view. Even those resources that are spread across different regions. And you can use CloudWatch dashboards to create customized views of your metrics, logs, traces and alarms for your resources. And Amazon Managed Grafana allows you to query and correlate metrics, logs and traces from different tools, then view and analyze them in a single visualization or dashboard. And with Amazon Managed Grafana, you can analyze your logs, metrics and traces without having to provision servers, configure and update software, or do the heavy lifting involved in securing, scaling, and also making Grafana highly available in production. So in the AWS Observability course, excuse me, you'll learn how to create and use dashboards both in CloudWatch and in Amazon Managed Grafana. So I'm just going to do a quick demonstration of CloudWatch dashboards. So I've got a dashboard here of my application, and actually what I've done here is I'm just using the metrics that I really care about for business reasons. So I care about availability, so I've got an availability metric. I care about how many visitors there are on the site, so I've got a metric to do with the number of sessions. Another interesting point here is using percentiles. So again, in the course we talk a little bit about percentiles, but if we were to look at the average page load time for my site, we'd probably see that there wasn't a problem. However, if we look at the 99th percentile, and that's if we look at 99% of the page loads, what's the highest, the maximum page load time of those 99%? It turns out it's 21.2 seconds. And that's not good. So we're also using data here from real user monitoring, which I'll talk about in a minute. And that's telling me that 93.5% of my page loads are under 2 seconds, 0.63% are between 2 and 8 seconds, but I've got 5.83 are over 8 seconds, and that's obviously not good. And I've got similar metrics here for my API response times. And I've got some other data here where I'm using information from logs using contributor insights to tell me where's my traffic coming from, what are my top 10 browsers, what are my top 10 operating systems, and what type of devices are accessing my website. Most of this traffic is being generated automatically by containers running in the background, so it's all mostly the same. But you can see I've got some data from other places as well. So this is just an example of one dashboard. What I also like to do with dashboards is create a little explanation at the top of the dashboard. What is this dashboard about? Maybe a link to the application itself, and then I like to add links to troubleshooting tools. So whether these be troubleshooting tools within CloudWatch or X-Rays, ServiceLens map, for example, or they could be to a wiki. And I also like to add alarms as well. So I'll add alarms, so I can see there I've got an alarm for one of my synthetic canaries. How do you monitor application performance? So we've got X-Ray that makes it easy for developers to analyze behavior of their distributed applications with the tracing capabilities. And you can use X-Ray, as we've shown, to identify performance bottlenecks, edge case errors, and other hard to detect issues. And X-Ray supports applications either in development or in production of any type or size, from simple asynchronous event calls and 3-tier web applications to complex distributed applications built using a microservices architecture. With CloudWatch RUM, real user monitoring, you can perform real user monitoring to collect and view client-side data about your web application performance from actual user sessions in near real time. And the data that you can visualize and analyze includes page load times, client-side errors, and user behavior. When you view this data, you can see all of it aggregated together, and you can also see it broken down by different browsers and devices and device types that your customers use. We've also got CloudWatch Synthetics that allows you to create synthetic transactions designed to simulate user activity against your web applications or APIs. And you can use these transactions to continuously test performance and availability in production and in other environments. You can test functionality prior to deployment, and you can also test for broken or dead links and do visual monitoring for comparing to a baseline. So you could maybe check for if somebody has managed to deface your site. This is also useful for smoke testing after a deployment as well. And in the observability course, you'll learn how to monitor application performance with X-Ray and use real user monitoring and CloudWatch Synthetics. So I'll do a quick demonstration now of CloudWatch Synthetics. So we find CloudWatch Synthetics under Application Monitoring and Synthetic Canaries. And I'm going to show you a workflow. So this is where I'm mimicking somebody going onto my website, inputting some data, and just checking that that's working properly. And what I'm going to do is look at the screenshots. And this gives you an idea of what's actually happening. So it starts with a blank page. It loads the page. It selects the input box. Then I type in a year. This is a random year between 1920 and 2020. And then what I'm doing is pressing the search button. This You've Been Hacked is to test the visual monitoring. And what I'm doing now is checking that the results that I'm getting match the year that I entered. Once I've done that, I know that it's worked, I know that it's successful, and that's completed. So everything's passed, and I can say that that's successful. If it hadn't been successful, I could then create an alarm on it not being successful, and obviously create an incident or send an alert. What about launches and A/B experiments? We can also do those. So you can use Amazon CloudWatch Evidently to safely validate new features and launch new features by serving them to a small specified percentage of your users while you roll out the feature. And you can monitor the performance of the new feature to help you decide whether to ramp up traffic to the new users or to users of your new feature. This helps you to reduce risk and identify unidentified consequences before you fully launch the feature. And you can also conduct A/B experiments to make feature design decisions based on evidence and data. And you can have experiments with as many as 5 variations at once. And Evidently collects experiment data and analyzes it using statistical methods. And it provides clear recommendations about which variation performs better. So you can test both user-facing features and back-end features, and this could be something as simple as, let's say, making a buy button bigger on an e-commerce site. Does making my buy button bigger lead to more people pressing the buy button? And in this course you'll learn how you can perform launches and A/B experiments using CloudWatch Evidently. So the course is available on AWS Skill Builder. This QR code will take you to straight to the course. And I will take some questions, so if you've got any questions I will take them. But I'm going to leave you with these three things before I take some questions. Observability is everything and operations are forever. As I said, think of the last time you decommissioned an application. Observability is essential for ensuring that you deliver for your customers and that you optimize performance and reduce costs. It's practically impossible to do it without observability. And obviously, please learn more about observability on this course on Skill Builder. So, thank you very much.